Hello, in this video I want to talk about the bitwise OR operator. As the name implies, bitwise works on the bit level, so it works with binary numbers, zeros and ones. Before we get started, we got four cases to cover. This is the basics. Case number one, you got 0 or 0, and this results in a 0. If you perform bitwise on 0 or 0, you get a 0 because neither of the operands is a 1. Case number 2 is 1 or 0. This results in a 1 because one of the operands is a 1. Case number 3 is 0 or 1. This also equals 1 because one of the operands is a 1. And the last case is 1 or 1. And this also gives you a 1 because one of the operands is a 1, and it doesn't matter which one. It's only important that one operand is a 1. This is all you have to remember, these four cases and these results. So you only get a 0 when both operands are 0. Now let's get to an example. Let's bitwise OR together the hexadecimal numbers, and hexadecimal numbers in most programming languages are prefixed with this 0x. So let's perform bitwise on 0x123 and hex 99A. As I said, bitwise works on the bit level in the binary format. The first step we have to do is to transform these hexadecimal numbers into binary. If you don't know how to do that, I got a video for you in the description down below that covers this topic. So now we convert. We start from left to right. We begin with the 1. 1 in binary is 0, 0, 0, 1. The 2 in binary is 0, 0, 1, 0. And the 3 in binary 0, 0, 1, 1. Now let's get to hex 99A. Again from left to right. The 9 is in binary is 1, 0, 0, 1. 1, 0, 0, 1. And the A is 1, 0, 1, 0. Now let's perform bitwise OR. We go from right to left. We start here. 1 or 0. 1 or 0 gives you a 1. 1 and a 1 is a 1. 0 and a 0 is a 0. 0 and a 1 is a 1. 0 and a 1 is a 1. 1 and a 0 is a 1. 0 and 0 is 0. 0 and 1, 1. 1 and 1 is 1. 0 and 0 is 0. 0 and 0 is 0. And 0 and 1 is 1. So our result, if you perform bitwise between these two hexadecimal numbers, is 1001, which is a 9, 1011, which is B, and 1011, which is B. Now, if you take a closer look on the second operand, you basically set a bit where on the first operand no bit is set. This is the case here. Our 0 hex 123, the first operand, this bit is not set. And with the bitwise OR, we basically set the bit where no bit is set. And this is also the case here. This isn't the case here because the first operand has this bit already set and we do basically nothing. We leave it as it is. The same is here. Here we set the bit because there is no bit set. This we leave it as it is, here and here also. And here is the last case where this is true. We basically set the bit where no bit is set. In general, you can say you can use bitwise OR to set bits where no bits are set. Now you might say this is all great, but what practical use does it have? Now let's have an example. Let's say you got a nice microcontroller. This microcontroller has a CPU built in, and this microcontroller has 8 pins, 1, 2, 3, 4, 5, 6, 7, 8. And there is a LED connected on each pin. 2, 3, 4, 5, 6, 7, 8. And the CPU of the microcontroller contains a register. Let's bring in a graphic. Let's make it a little bit bigger, if I can. And this register has the following value. Let's say 1, 0, 1, 1, 0, 0, 0, 1. So this means wherever a bit is set, the LED is on. So the first LED is on, the second is off, the third and the fourth are on, 5, 6, and 7 are off, and the last one is on. Now let's say you want to turn on this LED without turning the other LEDs off. The process might be you ask the CPU to give you the value of this register. So you basically read the register, and the microcontroller might respond with the hexadecimal representation of the contents of the register. So in this case, 1011 is a B, might respond with 0xB1. And now you have to figure out the correct value for the register, which turns this bit into a 1 without touching the other. And as we have learned above, not touching the others means you put down zeros wherever you want the value to remain, and you put a 1 where you want the value to be changed. So this binary number in hexadecimal is 0x4, and you can omit the leading zeros. So basically 0x04 is assumed, so you don't have to put down the 0. And now you perform bitwise OR between 0xb1, the original value of the register, with 0x4. Let's do that. Let's write down b1. This 1 is 0, 0, 0, 1, and the 4 0, 0, 0, 0. So the omitted zeros 0, 1, 0, 0. So which is hexadecimal 4. Now let's order this together. 0 and 1 is 1, 0 and 0 is 0, and here's the part where we flip the bit. 0 and 1 is 1, and the rest remains the same. Oh, the same as it. 1, 1, 0, 1. So the result is 0xb5. This is a b, this is a 5. And we write back this result into the register. We write 0xb5, which turns this 0 into a 1. And the LED may turn on. Now let's have another example. Let's put this back to a 0. And let me erase the rest. Will be done soon. So now we want to turn on two LEDs at once. We want to turn on this LED and also this LED. So we do the same. We create our bit mask. We don't touch this bit, don't touch this, don't touch this, this. We want to change this bit, and we also want to change this bit. So this binary number in hexadecimal is 0x. We can omit the leading zeros. And now we OR together the original contents of the register with our mask 0x6. We do 0, 1, 1, 0, 0, 0, 1. And we don't have to put down the leading zeros if we don't want to. We can just, this is hexadecimal 6, binary 6, sorry. And we OR together, 1 and 1. 1 and 0 is 1, 0 and 1 is 1, 0 and 1 is 1. So here we changing the bits and we just leave the rest untouched. And we get as a result B7 this time, 0x B7. And we write this back into the register. Oh, that's not nice. 0x B7. And now both LEDs are on. So you see, this is not magic. And with some practice, you can basically do this operations in your head. You just have to remember a few things, how to convert hexadecimal numbers into binary. And yeah, that's all about this topic. Thanks for watching and goodbye. Have a nice day.